Hello, it's Keith here, and this is lesson 3 of the SuckShoot series of my ARM assembly programming tutorials. We're looking at SuckShoot again. This time we're looking at the Nintendo DS version. Now the Nintendo DS version is actually a port of the Game Boy Advance version. It's been tweaked just relatively slightly because the two systems are surprisingly similar, and so rather than discuss the entire code again, what we're going to do this time is we're going to compare what's had to be changed to this version. So if you need to see more details of how the code works in general, please see the Game Boy Advance edition where we go into some detail on that. Today we're really going to focus on what's been changed. So you can see the game here. You can see we've got our SuckShoot text on the screen and our bat, and if I can remember the controls, we've got our gameplay here as before, and we can now shoot our bats. Now the first thing that is had to change is the code that handles the coordinates of the screen, because the screen is actually bigger on the Nintendo DS. While the screen memory layout is very similar, the screen is actually bigger. So that's one thing that's had to change. What hasn't had to change is the sprites. The sprites are in exactly the same file format as last time. We've exported the bitmap data for the Game Boy Advance, and we're using that same exported file for the Nintendo DS version because the screen memory is the same. It's just the code that transfers the byte data to the screen that's been tweaked. Okay, well, let's go over to our code and let's take a look and let's see what's changed. Okay, so here is the start of our program here, and the first thing that's changed is the memory address of the RAM that we're using. The RAM that we're using for our variables now is at 2F and 5 zeros. We were at 2, 6 and 6 zeros before, so we've changed the memory address, and that's because the other area of memory is actually being used by our program code on the Nintendo DS. So we've had to change that. We've also had to change Chibi Sound. Chibi Sound needs 2 bytes now. That's my simple sound driver. The reason it's different is that the way the sound works is very different on the Nintendo DS. The sound chip is actually part of the ARM7. We can't access it from the ARM9. So we've actually got a sub-program on the ARM7 here, which is my alternate Nintendo DS Chibi Sound driver, which is running on the ARM7, and then the ARM9 has to talk to the ARM7 to send the sound across, and we need 2 bytes to do that. One is a marker for when the byte has changed, and the other is the byte that's being transferred to the other CPU. I've covered the Chibi Sound drive in the platform specific series, so please take a look at that. The only point I'm making here is the fact that the sound driver has had to change in a significant way because to port to this Nintendo DS system from the Game Boy Advance. Now, at the start of our code, we've got a different header, of course, but we're not going to go into that in any detail here. But at the start of our program here, we are setting up things, and while we're basically setting up the same screen, we do need a lot more initialization commands here to get everything set up correctly. We need to set up our graphics, we need to turn on the LCD control, and we actually need to enable the memory. So a few extra commands here to get our screen set up before the program starts. Now, our clear screen routine, if we go down to this here, our clear screen routine is working at a different memory address. Now, the Nintendo DS version is using the memory address 68 and then 5 zeros here as the base for the VRAM, but on the Game Boy Advance it was 6 and then 6 zeros, so the memory address has changed, and the screen size has also changed to 256 by 192. Now we're transferring in 32-bit words here, so we're dividing that by 2 because we're effectively doing 2 pixels per transfer here, but that is clearing our screen for us. Now, of course, the print char routine has also changed. The VRAM base has changed, and the size of each line has changed for the calculations there. The other thing that has, of course, changed is the show sprite routine. This has also had to change its memory base to 68 and 5 zeros from 6 and 6 zeros. That's the base has changed, and of course the calculations to calculate the XY coordinate that we're drawing to have changed because the width of the screen has changed to 256 pixels. So again, that has been changed. Now at the start of our code, if we just go to our main loop here, we've had to change the width and height coordinates as well to adjust for the screen size change. And we've also had to change the text drawing locations, although I think actually the game over location isn't quite central. I think maybe I'd need to correct that again. But it does basically work. Now, one important thing to notice, one quite interesting thing to notice is the read joystick routine has not changed. The read joystick routine is exactly the same as it was before. We can basically read in the primary directions, the up, down, left, right, and the 2 fire buttons and select and start, from the same memory address as we could before. So this has not changed. But what has changed though is if we want to read in the extra buttons that were added with the Nintendo DS, we actually have some difficulties doing that. We have to do that from the second CPU. So if you're just using the basic buttons, you're not going to have too much trouble porting. But if you do want those extra buttons, it is going to be a little bit more difficult. But basically, the vast majority of the code hasn't actually changed between the two systems. So despite the fact that the hardware is much more advanced on the Nintendo DS, they basically use the Game Boy Advance as a template, and so we've got the functionality there. And I'm sure part of that is because the Nintendo DS is backwards compatible with the Game Boy Advance. So there we go. Anyway, you can go to my website and you can download the source code for today's example as always and have a go with it. And as I say, as always, you're welcome to use in any of your own projects, even if they're commercial. Good luck to you. That's what it's there for. Try and make some use of it. I hope you've enjoyed this. If you have, please like and subscribe, because if you like the videos, YouTube recommends them to more people and it encourages me to keep working on projects like this. And if you subscribe, you'll see what's coming next. What I've got next on the ARM systems is I have a RISC OS port of SuckShoot, so this little game is coming to the RISC OS system. So if you are a general ARM interested person, please stick around for that. Anyway, hope you've enjoyed what you've seen today. Thanks for watching and goodbye.